Welcome to this explainer. Today, we're diving straight into the complex and, let's be honest, sometimes confusing world of modern tactical communications. We are going to decode the absolute alphabet soup of acronyms out there. Looking at the source material, I realized pretty quickly that these systems are definitely not one size fits all. So we're going to unpack the specific differences between SDR, MANET, and IP radios, outline their distinct use cases, and really explore the unique benefits of each one. You know, people ask this all the time. Are SDRs actually better than MANET radios? They mistakenly think these technologies are competing for the exact same job. But diving into the research completely changed how I view tactical comms. These aren't competing devices at all. They are entirely different pieces of the exact same puzzle. So here is exactly how we're going to break this down today. First, the tactical comms confusion. Second, SDR signal processing. Third, MANET dynamic networks. Fourth, the dual meaning of IP radios. Fifth, the layered reality. And finally, unifying with Sigma.
All right, Section 1, the tactical comms confusion.
Let's start right at the root of the problem. Treating distinct communication layers as if they are just one-size-fits-all pieces of hardware. It's incredibly common to hear requests for an IP radio when what's actually needed is a specific network behavior. These terms describe entirely different things, like how a radio processes signals, how it networks, or how it interfaces. Once we stop viewing them as competing standalone devices, the whole architecture really starts to make sense.
Moving on to Section 2, SDR, or Agile Signal Processing.
Okay, so let's look at our first major technology category, looking at what happens inside the radio itself. An SDR, which stands for Software-Defined Radio, basically shifts the heavy lifting of radio signal processing from conventional hardware over to flexible software. Think about what this means for a second. You aren't permanently locked into the physical circuitry that the radio originally shipped with. So instead of being stuck with fixed physical circuitry, where changing your mission basically meant buying and lugging around a whole new radio, SDRs use software updates. You can dynamically tune across multiple frequency bands, switch waveform types, and even support new encryption protocols on the fly. It's a real game changer. Now, the huge pro here is that SDRs make your radios future-ready. This is absolutely crucial for modernization efforts like JADC, Joint All-Domain Command and Control, where you really have to adapt rapidly to evolving standards. But of course, there's always a trade-off, right? The incredible flexibility of SDRs brings software complexity, and that introduces some pretty rigorous cybersecurity validation challenges. Plus, all that programmable processing power, it definitely costs more in terms of power consumption compared to a simple fixed hardware circuit. All right, Section 3, MANET, which stands for Self-Healing Dynamic Networks.
Building on the hardware side of things, MANET is all about network behavior. Notice that you aren't technically using a MANET radio, you are using a radio that has MANET functionality. In this setup, there is no master hub. Every single radio or node acts as both a user and a router. If someone sends a message, it can hop from radio to radio until it finally reaches its destination. The use cases here for the tactical edge are just phenomenal. Think about it. In a fixed infrastructure, you rely on static cell towers or direct line of sight. If a mountain gets in the way or a tower is destroyed, you lose comms. In a MANET, nodes form dynamic networks on the move. As units maneuver around obstacles, the network automatically self-heals and adjusts its routing topology. It extends your reach way, way beyond simple line of sight. But again, we have trade-offs. Getting this incredible self-healing resilience in contested environments comes with some performance overhead. Bouncing a signal across multiple nodes to get over a hill takes time. Multi-hop throughput and latency can degrade, and the constant routing chatter between nodes adds serious overhead and complexity to the network. It's a massively powerful tool, but you really have to plan for that latency.
Which brings us to Section 4, IP radios and their dual meaning.
According to our sources, this is literally the most ambiguous term out in the field right now. It causes so much confusion. You absolutely have to separate these two concepts. On one side, we have IP data over RF. This just means the radio transmits data directly over the air as standard IP packets. This is how you move video and situational awareness data across your radio network. On the other side, we have RTP-based PTT audio. This is specifically about how push-to-talk voice interfaces into a larger system, like a command center, using IP packets instead of a traditional clunky analog audio cable.
These two concepts have absolutely no direct relationship to each other. A radio might support IP data over the air, but still rely on an analog cable for voice patching, or vice versa. Having that IP connectivity is an absolute game changer. It integrates tactical radios directly with broader IT systems and command and control platforms. It completely eliminates messy analog interfaces and allows for really flexible patching. But it completely depends on available bandwidth and network reliability. If your RF environment is congested, well, your IP traffic is going to suffer. And remember, not all tactical radios actually support RTP-based audio natively, which means you have to do some special planning for interoperability.
Okay, Section 5, the layered reality.
This right here was the ultimate aha moment for me when looking into this. These three things, they're not competitors. It's a layered reality. SDR is the hardware processing. MANET is the networking. IP is the transport. A single modern tactical device can actually do all three at exactly the same time, stacking together for ultimate capability. Let's wrap it up with Section 6, Unifying Comms with Sigma. So if we have all these disparate layers, how do we actually tie them all together? Well, the sources point to solutions like the REDCOM Sigma ecosystem. Acting as sort of the software-centric glue, Sigma works with SDRs, MANET nodes, and IP systems across any vendor. Through radio over IP or ROIP, it seamlessly links smartphones, SATCOM, and tactical nets. Operators get a single pane of glass to monitor and patch all of this in real time. And hardware like the Sigma XRI serves as a tactical gateway, bridging legacy analog nets right into modern IP networks. Understanding modern tactical comms isn't just about memorizing an alphabet soup of acronyms, it's about recognizing how these architectural choices stack to create true mission flexibility. This summary says it all perfectly. SDR gives you the agility, MANET gives you the resilience, IP brings it into a unified network, and software like REDCOM Sigma allows you to command and control that entire unified picture seamlessly. And that is the critical question I want to leave you with today. As the battle space evolves, think about where your own network might be fragmented. Are you still treating layers as standalone devices, or are you building a truly interoperable architecture? Thanks so much for joining me on this explainer as we unpack these layers, and stay curious.